Welcome to the debate. Today we're diving into, well, one of the most talked about decisions in modern astronomy, certainly one that stirred up a lot of feeling. The International Astronomical Unions, that's the IAU, reclassification of Pluto back in 2006. It went from being the ninth planet, everyone learned that in school, to this category of dwarf planet. And that really sparked a huge amount of discussion, both scientifically and publicly, challenging how we even define what a planet is.
Exactly. And that brings us to our central question today. Was Pluto's reclassification a scientifically sound, necessary step that brought clarity? Or was it maybe a flawed decision, perhaps a bit premature, that kind of overlooked Pluto's own planetary nature and just stirred up controversy?
And this all comes out of, a lot of scientific papers and ongoing discussion in the astronomy community. My position is that the reclassification, while maybe difficult for some, was actually a critical move towards a more logical way of categorizing planets, especially with all the new things we were discovering out there.
And I'll be arguing the other side, that the 2006 IAU definition itself was frankly problematic. It didn't have universal buy-in, and it ended up demoting, and I use quotes there, a really fascinating world based on, well, what I see as an incomplete picture and a maybe slightly questionable process.
Right. So from my perspective, the IAU's 2006 resolution wasn't just necessary, it was scientifically justified. It brought some much-needed precision to the word planet. I mean, that term had gotten really ambiguous. Think about it. Before 2006, the idea of a planet was pretty broad. And then we started finding things like Eris, which turned out to be even more massive than Pluto. That really forced the issue. We couldn't just keep adding every big round thing to the list without, a better framework. So the IAU came up with 3 criteria. 1, it has to orbit the sun. Okay, Pluto does that. 2, it needs enough mass for its own gravity to pull it into a nearly round shape, what we call hydrostatic equilibrium. Yep, Pluto does that too, it's pretty spherical. But then number 3, crucially, it has to have cleared the neighborhood around its orbit. And that's where Pluto fails. It shares its orbital path with lots and lots of other objects in the Kuiper belt, and it even crosses Neptune's orbit. So it clearly lacks what we call dynamical dominance. And actually, more recent work proposing something called a fundamental planet plane, which uses physical properties like mass, radius, and moment of inertia, seems to back this up. It shows Pluto clustering more closely with moons than with the 8 major planets. It provides a solid physics-based reason for classifying it differently.
I'm sorry, but I just don't see the 2006 decision as this great moment of scientific clarity. To many, myself included, it felt more like an administrative act. And it definitely caused a lot of ongoing controversy, mainly because, as I see it, the definition itself is flawed, and the way it was adopted wasn't exactly a model of consensus. That third criterion, clearing the neighborhood, that's the real sticking point for me. It feels ill-defined and, honestly, inconsistently applied. I mean, let's dig into that. Think about Jupiter, massive planet, right? But its orbit includes, at least 100,000 Trojan asteroids traveling with it? Has Jupiter really cleared its neighborhood in an absolute sense? And Earth, our own planet, we share our space with thousands of near-Earth objects, sometimes even temporarily capturing little mini-moons. So if these major planets haven't perfectly cleared their orbits, what does that rule actually mean in practice? It feels flexible. And forget applying it to exoplanets, we just can't observe other systems well enough yet to know if they've cleared their neighborhoods. And then there's the naming thing. A dwarf galaxy is still a galaxy. A dwarf star is still a star. So why isn't a dwarf planet still a type of planet? It seems linguistically illogical, almost designed to diminish it. And it overlooks Pluto's amazing features. The mountains, the glaciers, the potential ocean, the New Horizons probe showed us. These are planetary features. Even the former head of NASA, Jim Bridenstine, said publicly he thinks Pluto's a planet. That tells you something about the lack of universal agreement, doesn't it?
Let's focus on that clearing the neighborhood bit, again, because it really is central. As the source material notes, Jupiter's got those 100,000 Trojans, Earth has its NEOs. If the big planets don't meet this criterion in a, perfectly clean way, what's the threshold?
How clear is clear enough? It feels subjective. And think about this hypothetical. If you took Earth exactly as it is and somehow placed it way out beyond Neptune, it might suddenly not be the dominant gravitational body in its region. It could be influenced by a big ice giant. So by this definition, Earth would cease to be a planet just because of its location without changing anything about Earth itself. That really highlights how context-dependent and, well, maybe arbitrary this definition is. It seems less about the object's intrinsic nature and more about its current zip code.
Okay, I see why you'd frame it like that, and I agree the phrase clearing the neighborhood maybe wasn't the clearest choice of words if you take it absolutely literally. But the underlying concept isn't about achieving perfect emptiness. The idea, often termed dynamical dominance, is really about whether the object is the main gravitational player in its zone. Did it, through its formation, either suck up or fling out most of the other smaller bodies, the planetesimals? It's about being the gravitational boss, the big kid on the block, essentially. And this can be quantified, often using a parameter people call lambda, which basically compares the object's mass to everything else sharing its orbital space. High lambda means dominance. And Pluto, well, its lambda value is way lower than the 8 planets. It's clearly swimming in a sea of comparable Kuiper belt objects, and as you said, it crosses Neptune's path. So it's not about perfect emptiness, it's about the degree of gravitational control. And yes, applying this specific criterion to exoplanets is tough right now because of our technology. We just can't see the smaller stuff around them yet to measure their clearing ability. But the principle works for our solar system. The IAU needed a way to distinguish the truly dominant bodies from those that are part of a larger crowd. So while Jupiter has Trojans, its overall gravitational influence in its zone is just orders of magnitude greater than Pluto's in its zone. It's about relative clout.
I understand the idea of dynamical dominance in this lambda parameter, sure, but the practical side still bothers me. If it's a matter of degree, where is the exact cutoff? Is there some magic lambda number that everyone agrees definitively separates a planet from a dwarf planet? The criticism isn't just that it's ambiguous, it's that there isn't a sharp, universally accepted scientific line. And like I said, if Earth classification could change just by moving it, doesn't that make the definition feel less fundamental? Less about what the object is and more about where it happens to be right now? That seems to undermine its usefulness as a core classification.
That's a fair point about finding a single perfect numerical threshold. And, science is always refining these things. But even without one universally agreed upon number down to the decimal point, the difference in dominance, the difference in those lambda values between the 8 major planets and things like Pluto is enormous. It's like comparing a whale to a minnow in the same patch of ocean. The major planets are, for all practical purposes, alone in their cleared zones, in a way Pluto simply isn't. And yes, context does matter in taxonomy. Think about biology. An organism's environment shapes its classification sometimes. Here, an object's gravitational interaction with its surroundings is a key characteristic. It tells us about its formation, its history, its role in the system. Which brings me back to your point about the IAU decision being administrative. Maybe the process wasn't perfect, but the need for some kind of clearer definition was scientifically undeniable, given the discoveries being made. And to build on that, it's true the IAU definition sparked debate. But that debate also spurred new science, which is good. Take that fundamental plane idea I mentioned. That's a newer proposal, looking at things more physically, quantitatively, moving beyond just the orbital dynamics. It's using core properties, mass, radius, and the moment of inertia. Now, moment of inertia, that basically tells you how mass is distributed inside an object. Is it dense in the middle? Is it differentiated into layers like a core and mantle? It's a clue to the object's internal structure. And this analysis, this newer research, it clearly shows Pluto having, and I quote, most similar properties with moons. It plots onto the moon plane in their model, not the fundamental planet plane where the 8 major planets sit. So this isn't just some arbitrary label. There seems to be a real physical basis rooted in intrinsic properties for grouping Pluto separately.
It's not a demotion, it's aiming for a more accurate scientific category.
While I'm still not entirely sold, especially thinking back to the original decision itself, the issue wasn't just the definition, but the whole process. It felt very top-down. As the source material mentions, many astronomers, especially outside the core group, felt dissatisfied because the definition was developed in a very narrow circle. That lack of broad consensus building is bound to cause problems and lead to pushback. It felt less like science finding agreement and more like a committee making a ruling. And I still struggle with the term dwarf's planet. Dwarf stars are stars, dwarf galaxies are galaxies. The term itself implies it's a type of planet, yet the definition is used to say it isn't a planet. It's confusing and, frankly, sounds like a lesser category. Now, these new models like the fundamental plane, interesting, definitely, good science to pursue. But do they retroactively fix the flaws in how that initial 2006 decision was made and communicated? I don't think so. It still felt rushed and failed to fully embrace the sheer diversity of worlds out there.
I understand the concerns about the process and the name. Look, scientific consensus building takes time, and big changes always have critics. But the IAU, as the body responsible for this stuff, faced a real classification problem that needed addressing. The discovery of Eris and other large KBOs forced their hand, and this fundamental planet plane isn't meant as a retrospective patch-up. I see it as new evidence that supports the idea that there is a meaningful physical distinction between the Big Eight and objects like Pluto. The fact that Pluto's basic physical parameters, its mass, size, internal structure, make it cluster with moons in this analysis, that suggests a fundamental difference. Maybe dwarf planet isn't the perfect name. Maybe we'll refine it. But the science was pointing towards needing a distinction based on both dynamics and potentially intrinsic properties reflecting formation history. The new data just gives us a clearer, physics-based way to see that distinction.
Okay, but let's step back from the definitions and the models for a second. Let's talk about Pluto itself. What is it like? Because the New Horizons mission just blew everyone away, didn't it? It showed us this incredibly dynamic, complex world. Cryovolcanoes erupting icy slush, vast glaciers of nitrogen ice flowing across plains, maybe even a subsurface liquid water ocean. These are signs of active geology, internal differentiation, things we associate with planets like Earth or Mars. So to take a world with all these fascinating planetary processes happening and say it's not a planet because it hasn't, completely cleared its neighborhood, a criterion we've already established is a bit fuzzy and one that even Mercury doesn't perfectly meet in terms of hydrostatic equilibrium, doesn't that feel like we're letting the classification tail wag the scientific dog? Aren't we diminishing our appreciation for this amazing world by sticking too rigidly to one definition?
That's a really powerful point, and I absolutely agree. Pluto is fascinating. New Horizons was incredible. Its geology is complex, active, and hugely important for understanding icy worlds. Pluto's scientific value is immense, regardless of its label. But the goal of scientific taxonomy of classification is to group things based on shared characteristics that define a class. And the fact remains that Pluto exists in a crowded neighborhood, the Kuiper Belt, sharing space with many other substantial objects. And, as that fundamental planet-plan analysis suggests, its core physical properties align it more closely with large moons than with the 8 planets that do dominate their orbits. So the classification isn't meant to diminish Pluto's complexity or importance. It's about creating a consistent framework. Think about moons, many moons, like Europa or Titan, are geologically active, fascinating worlds, but we classify them as moons because they orbit a planet. Here, Pluto's orbital context and perhaps its fundamental physical parameters place it in a different category than the 8 dynamically dominant planets. It's about distinguishing different types of objects based on a combination of factors.
But isn't the very idea of planet meant to capture that sense of being a world with complex internal processes, geology, maybe an atmosphere? Shouldn't those intrinsic qualities weigh more heavily than just its orbital situation? When a place has mountains, glaciers, possibly oceans, features we see on acknowledged planets, calling it not a planet based on that clearing rule still feels like it misses the forest for the trees. The dwarf planet label, for many people, scientists included, just doesn't capture the essence of what Pluto is. It feels like it undervalues these active, diverse worlds beyond Neptune.
I understand that emotional connection and the intuitive sense that Pluto feels like a planet, but the IAU definition was specifically crafted to differentiate the 8 classical planets, the ones that grew massive enough early on to gravitationally dominate their formation zones from everything else. As I mentioned, many large moons are incredibly complex worlds, geologically active, differentiated, but their defining characteristic in classification is that they orbit a larger body. So while Pluto's intrinsic features are absolutely planetary in many ways, the classification also had to account for its context, its shared orbit, its place within the Kuiper Belt population, its formation history, which differs from the Big Eight. The goal wasn't to devalue Pluto, but to create a more nuanced system that recognizes different classes of objects, including this category of dwarf planets, which share some planetary traits but differ crucially in their dynamical role.
So as we wrap up, it's really clear that defining planet and figuring out where Pluto fits, well, it's still a live issue in astronomy. It's a complex business, and our definitions have to adapt as we learn more. My view, as I've argued, is that the 2006 IAU decision, despite the controversy, was a necessary step towards a more scientifically coherent system. And newer work, like that fundamental planet plane model, seems to provide further physical justification for distinguishing Pluto and similar objects from the 8 major planets based on their core properties.
And from my side, I've emphasized that the IAU definition, especially that clearing the neighborhood part, remains problematic. It felt like an administrative move lacking full consensus, one that perhaps undervalued Pluto's clear planetary characteristics. And the fact that the debate continues so strongly, even involving NASA leadership, really shows this isn't a settled question.
Absolutely. This whole discussion just highlights how tricky scientific definitions can be, especially when faced with new discoveries that stretch our old categories.
Right. And hearing these different perspectives just underlines how important ongoing research, debate, and, respectful disagreement are for actually deepening our understanding of the universe. There's clearly still a lot more to figure out when it comes to classifying the amazing variety of objects out there.